Right, I want us to look at the GP, or the geometric progression, or the geometric sequence, particularly the sum. If formula sum, it Sn is equals to A into R to the power n minus 1 divided by R minus 1. This is important. However, it can also come in this form. Sn is equals to A into, remember this one, R. The second one can start with 1 minus R to the power n minus the same thing over 1 minus R. Now, how do you see which one to use? The problem here will be your denominator. If R wako mkhulu no 1, R ubangala. In this case, if 1 mkhulu no R, 1 ubangala. So in other words, inamba bangala, inamba enkulu kunenamba encane la, so that we'll have a positive denominator. Uma ku 1 gala nalapha 1, uma ku R la nalapha R to the power n. Fortunately, we're given both these formulae in our data sheet at the end of the question paper when we write our tests and classworks and examinations. But we know that generally, if we've got a geometric sequence like 2, 4, 2 times 2, it's 4, 4 times 2, it's 8, 8 times 2, it's 16. Why the formula? Why 7 is a formula? It's only that when we've got big numbers, we can find the formula. But we know that S1 in this particular sequence would be what? It will be the first term. S1, T1, and A is one and the same thing. But what is T2 there? T2 is 4. What is S2 there? Remember, T2, in this particular case, is the second term. It is 4. What is S2 then? What does S2 mean? S2 means the sum of the first 2 terms. What is the sum of the first 2 terms? In this particular sequence, it is 6. What is S3? It will be 6 plus 8. What is 14 in that particular case? Let's move on. We know that generally, let's see where does this formula come from. We know that Sn, when we add our sums, right, we know the general term. We know the general term of the geometric, which is this one in particular. This is the general term. Tn is equal to A times R to the power n minus 1. This is the nth term. This is the last term, the general term. When we add, we start to add from the first term. Generally, the first term is called A. Let us add the second term. What will be the second term? The second term is A times R. It will be A times R. Because that's how you move from this term to the second term. You multiply it by the common ratio, which is 2 in this case, to come to the second term. To go to the third term, it's going to be A times 2 times 2. How many R's there? R squared. That's where it comes from. So the third term will be plus A R to the power 2. That will be the third term. We can add this term up to the last one. What is the last term? It is the nth term. The nth term. It is the last term. So the nth term means the last term. In this particular case, it's going to be AR to the power n minus 1. This is the last term. But I should know that I will have a term just before this one. Just before this one. I will have another term there. That term will be AR to the power n minus 2, the one before this one. It will be AR n to the power minus 2. Let me just write it. AR to the power n minus 2. This is the one before this one, and you can find the one before that one as well. But I was only interested in that particular one in particular. Right. The next step, you've got to take this, I've got to multiply it by R times Sn. Let me just call this equation 1. To find equation 2, I take equation 1, give multiplying R. That's how I find my second equation. So Sn, when I multiply by R, then this will be equals to, if you multiply this by R, what do I have? I will have AR. But the way that I've got to put my AR, I work smartly. AR. So I will miss the first one and go and put it under the second term. of the first equation. So when I multiply the first term by r, I will have AR. But I'll put my AR here, A times R, so that when I'm adding these two, will cancel each other. Because I might not see it when I'm putting it here. Now, since as I'm putting this, the first one here, I will have another odd one which will be on its own at the end there. Right. So if I multiply the second one by r, so if you multiply this by r, it will be AR to the power 2. I will put it under that one, AR to the power 2, so that they will be the same. Right, let's look at this one. If I multiply this by r, remember this is the same as A times r to the power n times r to the power minus 2. It is exactly like that. If I multiply this by r to the power 1 by r, so these two will be what? They will end up being r to the power, what is minus 2 plus 1? It is minus 1. AR to the power minus 1. So that's where this will give me that one. In this particular case, it will be plus AR to the power n minus 1, no longer 2. Remember that even this one, I've got to multiply it by r as well. If I multiply this by r, remember that this is r to the power minus 1. So if I multiply r to the power minus 1 by r to the power 1, minus 1 will go with that positive 1, and I'll be left with AR to the power n. That's what I have now. That is what I will have. Let's see what happens next. Let's do this thing. Remember, this is equation 1. Let's call this one equation 2. Now, if I want to get the first one, if I want to get this, I will have to say equation 2 minus equation 1, which will be equals to. But if I want to get to the first one, I will say equation 1 minus equation 2. That's how we find them. Let's do this thing. We are saying equation 2, which is this one, which is r Sn minus equation 1, which will be equals to Sn. What is this equals to? Okay. This minus that, kasuga. This minus that, it will go. There's one before this is ohamba nale, yeah? This one goes with that one, sisele nale, ngezansi. And this one. So those are the two one left ngezansi, no one left ngaphezulu. So we are going to say AR to the power n in this case, which is the odd one, minus this one. It's minus A. All right, that's the step, that's the stage ebesifuna ukusithola. Once we are in that step, we work it out. Remember what is funantin. I have eyes. When I look at this side, of number times out 2. When I look at this side, number times out 2. And we are able to say, in this particular case, we've got a common factor of Sn. Sn, if I take Sn this side, what will I be left with? I will be left with R minus times by Sn times 1. So when I multiply this, I get that as it is. Sn times R, it will be Rsn. Sn times minus 1, it will be minus Sn. Is equals to the same thing that I see there, a common factor, something that is the same in these two terms. What is a common factor here? Of course, it is A. If I take A out here, I'll be left with R to the power n in this particular case. R to the power n minus 1. Right, this is what we have. Remember, we want to come to this formula, we develop. It's about 5 to 6 marks in your examinations, and it's a giveaway marks. These are giveaway marks. Make sure that you grab them. We want to make Sn the subject. If we want to make Sn the subject, what must I do? I've got to divide by R minus 1 on both sides. R minus 1. Let's see what happens here. This goes with that one. We're left with Sn is equals to A into R to the power n minus 1 over R minus 1, which is exactly what we wanted to get. So it is true that Sn is equals to A into R to the power n minus 1 all over R minus 1. Remember, if you want to prove this one, here you will say equation 1 minus equation 2. You'll get that one exactly as it is. Thank you.